New syllabus Mathematics 7th edition, Book 2, Exercise 1A, question number 10 from this exercise. If y is directly proportional to x and y equals 20 when x equals 5, find an equation connecting x and y. Second part from the question is to draw the graph of y against x. Okay, in the statement of the question we have given that y is directly proportional to x. So let's take this statement as y is directly proportional to x. So this statement can be written as y is proportional to x. As you know, if we remove this proportionality sign, then we are going to place constant k. So this equation becomes y equals constant k x. Okay, now to find the value of constant k, I am going to put the value of y and x from the statement of the question. So here the value of y is 20. So I'm going to put this value of y in this equation y equals kx. This equation becomes 20 equals k as it is because we are going to find the value of k. And x is 5, so this equation becomes 20 equals k multiplied by 5. Okay, to find k, let's take this 5 to the left side of this equation. Then this equation becomes 20 upon 5 equals k. Since 20 is the multiple of 5, it means 5 times 4 equals 20. So the value of k is 4. Constant k is equal to 4. Now by putting this value of k in this equation y equals to kx, this equation becomes y equals 4, which is the value of k multiplied by x as it is. Now this is the required equation connecting variables x and y. Second part from the question is to draw the graph of y against x. Now to draw a graph of y against x, first of all we need to find some ordered pairs for these two variables y and x. Okay, now to calculate ordered pairs for these x, y and x, I'm going to take this equation which is y equals 4x, which is basically the equation connecting x and y. So let's take the first value for x. When x is equal to 0, this is called input. And by putting this value of x in this equation, we can find the output, which is the value of y. So when x equals 0, by putting this value in this equation y equals 4x, we get the value of y, which is 4 multiplied by 0 equals 0. So first ordered pair is 0, 0. When x is 0, then y equals 0. Okay, to calculate the next second ordered pair, I'm going to take x equals 1, which is the input. Okay, with the help of this input we can find the value of y, which is the output for this equation. Y equals 4. What is 4? The value of k, which we have calculated. And x, this time x is 1, so 4 multiplied by 1 equals 4. So second ordered pair is 1 and 4. Okay, the third value for x is 2. So when x is equal to 2, which is input, the output y is 8. By putting this value in this equation, y equals 4, which is the value of constant k, multiplied by 2, which is the value of x. And then their product 4 times 2 equals 8. Same as I'm going to take another value for x, which is 3. By putting this value in the equation y equals 4 multiplied by 3, we get output y equals 12. Another value for x, I'm going to take 4. So by putting this value in the equation y equals 4x, the output y becomes 4 times 4, 16. So here we have 1, 2, 3, 4 and 5 ordered pairs. So first ordered pair 0, 0, which means x coordinate and y coordinate both are 0. 1 and 4, which is the second ordered pair. Here we have x coordinate 1 and y coordinate 4. Third ordered pair 2, 8, x coordinate 2, y coordinate 8. Fourth ordered pair we have x 3 and y coordinate 12. And the fifth and last ordered pair we have x coordinate 4 and y coordinate 16. Now let's plot these ordered pairs on a sheet of graph paper. So here I have a graph paper. We need to take two axes on this graph paper. First, horizontal axis, and the second one is vertical axis. Okay, now I'm going to take the values of x on this horizontal axis and the values for y on this vertical axis. So here we need to take a suitable scale for this graph paper. Like I'm going to take one large square. If you count the number of small squares, then we have 1, 2, 3, 4, 5 small squares inside a large square. So I'm going to take one large square equals 1 unit on x-axis on this horizontal line. So if you check the ordered pairs, the x coordinate starts from 0, 1, 2, 3, 4. So I need to take only 4 units on this horizontal x-axis. 0, 1, 2, 3, 4. So I will take one large square equals 1 unit on x-axis. Same as I'm going to take one large square equals 2 units on y-axis on this vertical line. So here in this ordered pairs we have the values for y, or y coordinates are 0, 4, 8, 12 and 16. So since I'm taking one large square equals 2 units on y-axis, so first is 0, which is the origin, second 2, third 4, 6, 8, 10, 12, 14, 16. You can take 18, 20, 22 and so on. So now first order pair, since we have 0, 0, x coordinate 0, y coordinate 0, so here we have the point of intersection. And the second order pair is x coordinate 1, y coordinate 4. So here is the x coordinate 1 and here we have the y coordinate 4. These 2 points intersect each other at this point, so this is the second ordered pair 1 and 4. Same as the third ordered pair is 2 and 8, x coordinate 2, y coordinate 8. This is the point of intersection for these 2 coordinates. And the next coordinate is ordered pair is 3 and 12. So x coordinate 3 units and y coordinate 12 units. So let's join them, we get the point of intersection. So this is our next ordered pair 3 and 12. And then the next ordered pair is 14 and 16, 4 and 16. X coordinate 4 units and y coordinate 16 units. So if you join these 2 coordinates, you will be getting a point of intersection here at this point. So now let's join these 1, 2, 3, 4, 5 points with a straight line. You can see this blue line is passing through these point of intersections. So this is the graph of y against x. So we get a straight line graph for this equation y equals 4x. When x equals 0, y equals 0, when x equals 1, y equals 4, and so on. So we get a straight line graph paper for this equation y equals 4x, and that's it. Another question, question number 11 from this exercise is if z is directly proportional to y. Again, we have given 2 variables, x, z and y. And then we have given their values, z equals 48 when y equals 6. Find an equation connecting y and x, z, and draw the graph of z against y. So first of all, I will write this statement, as we know that z is directly proportional to y. So the statement can be written as z is proportional to y, and then in the next step I am going to eliminate or remove this sign of proportionality, and I will place constant k. So this equation becomes z equals ky. Okay, now let's find the value of k. For this I am going to shift this y from right to the left side. The equation becomes z upon y equals k. Since we have given the value of z and y 48 and 6, so I will put z and y 48 upon 6 in this equation. Again, we have common factor between 48 and 6 is 2 and 3 and 6. So I will divide this 48 upon 6 by 6, because 6 ones are 6 and 6 times 8, 48. So the constant k is 48. By putting the value of constant k in this equation, we will be able to find equation connecting y and z. So z equals 8y. This is the required equation connecting y and z. Again, second part from the question is to draw the graph of z against y. So I need some ordered pair for y and z. So first I will be taking the value of y, which is input, output z becomes 0 because 8 multiplied by 0 equals 0. Okay, now second value of y is 1, so this equation z equals 8y becomes z equals 8. As it is y, since we have y1, so I'm going to put y equals 1 in this equation. 8 ones are 8, so z output z equals 8 when y input is 1. Okay, another value for y is 2, so then z equals 8 times 2, their product is 16. And the next or third order pair for y equals 3, the output of z equals 24 because 8 times 3 24. And when y equals 4, input, output z equals 8 times 4 32. So the ordered pairs are 0 0, first order pair with 0 x coordinate and 0 y coordinate, 1 8, 2 16, 3 24 and 4 32. Okay, again we need a suitable scale for this graph paper. So I will take this horizontal line as our y coordinate, y axis, and this vertical line as our z axis. So let's plot these ordered pairs on this graph paper. I'm taking one large square equals 1 unit on y axis, and one large square equals 4 units on z axis. So first large square equals 4 units, second large square equals 8 units, third large square equals 12 units, fourth large square equals 16 units, fifth large square 20, 24, 28 and 32. And on the horizontal y axis we have 1, 2, 3 and 4 units. Okay, now let's plot these points. First ordered pair we have 0 0, so this is the point of intersection. Second order pair is 1 and 8, x coordinate 1 unit, y coordinate 8 units. So this is the point of intersection for these two coordinates. Then the third ordered pair is 2 and 16. Let's join these two coordinates. So here we have point of intersection with the ordered pair 2 and 16. Another ordered pair which is 3 and 24. So if we join these x and y coordinates, we get a point of intersection over there, 3 and 24. And the next ordered pair is 4 and 32, so x y coordinate 4, and the z coordinate is 32. So here we have the point of intersection between these two coordinates. Again, I'm going to join these point of intersections with a straight line, and I'll make sure that this line passes through the point of intersection. So once again we have a straight line for this equation, z equals 8y.